In this video, our goal is to find the inverse function for the function given to us, which is f of x equals x divided by negative 3x plus 2. The algebra for doing this is rather complicated, so I wanted to take time to show you step by step how to work through this. So the first thing that I want to do is to rewrite the problem in terms of x and y, and I just do that so that I have easier variables to work with than the f of x notation. So my first step is literally a rewrite. And we know that f of x is equivalent to the y. So I'm just going to rewrite as y equals x over negative 3x plus 2. And then we know that the idea of the inverse is that it undoes whatever the function did, and that with between a function and its inverse, the x and y switch roles. So my next step is to switch x and y. So again, it looks like a rewrite, but this time wherever the y is, I put an x, and I put a y for both of the x's that were in the original problem. So I have x equals y divided by negative 3y plus 2. Now I have to work at reorganizing the formula to get it solved out for y. So my next steps are to actually solve for y. And in order to do that, because the fraction exists on the right-hand side of this formula, I am going to make the left-hand side of the formula also a fraction. So I'm literally going to put x over 1 just to make that a fraction. And over here I have y over negative 3y plus 2. And putting that into a fraction format on the left-hand side allows me to have this set up for a cross product. So I'm going to use my cross multiply, which is where I multiply diagonally. So I'm going to take the x and I'm going to multiply it by the entire quantity in the opposite denominator. So that gives me x times, and I'm putting this in parentheses, the negative 3y plus 2. Put my equal sign, and I multiply diagonally with the other two, and so 1 times y, which is real easy, it's just y. Now I can distribute. And so distributing in this first grouping, I get negative 3xy, and I typically write my variables in alphabetical order. And then I distribute to the next term, so I have plus 2x equals y. So here I'm going to take that deep breath, and I'm going to be like, what am I actually supposed to do? And so I look back here. My goal is to solve for y. So I want to get the two y values together, to get them on the same side of the equation by themselves. And so what I need to do is I need to take this negative 3xy term and I need to move this term. So move this one to the other side. And so because it is currently positive, what I'm going to do is add 3xy to both sides. And so the 3xy, the negative 3xy cancel, so I have 2x. And my y and my 3xy are not even like terms. So even though I've moved them over, they do not add together. So I have y plus 3xy. The reason why they're not like terms is because the one has an x variable with it and the other one does not. So when the variables don't match up, you don't have like terms. So I have a scenario where I have two terms on the right-hand side. Both of them have y in them, but they're not like terms, so I can't actually put them together. So this is what we saw in a previous problem, and our option here is to factor. And so on the left, I have 2x. On the right, I have a common factor of y. So I pulled it out in front, put some parentheses. In my parentheses are the remaining pieces that were not y, because I'm pulling out the common y. So on my first term here, it looks like I pulled out the common y and that term's completely gone, but I need it to be there so that if I would distribute, I would actually go back to the previous line of my equation. So I'm going to have to put a placeholder 1 so that when I distribute, I would get a y there. And then I have plus 3x as the remaining parts of that second term. So I'm going to off to the side here use a different color ink so that we can just double check this. We could distribute to check our factoring. So if I do that, what I had factored, I had y parenthesis 1 plus 3x. And so if I distribute, I would take the y times 1, which would give me y, and then I would take the y times 3x, which would give me plus 3xy. And when I do that, I see that that did work out, and I was right back to the previous line of my equation. So I double check that. And you can see how important that placeholder 1 is, because without that, I would not have the exact same thing as the previous line. So that is a nice way to double check that I factored correctly and that I'm doing the correct work so far. So finally, I want to get my y by itself because my goal has been to solve for y, and so I can divide on both sides. And so I'm going to divide here by 1 plus 3x on both sides. And so the 1 plus 3x as a quantity cancels. And so on the right, all I have left is y, put my equal sign, and my new formula is 2x over 1 plus 3x. And so this new formula is the formula for the inverse. Really important in the process of finding an inverse, there are 2 steps. Sometimes the second step is very complicated, as in this example. Sometimes it's much easier, but there are always 2 steps. And I do want you to know those 2 steps so that if I give you a problem, you would be able to, on your own, do the 2 steps. So the first step in writing in or getting to an inverse is switching your x and y. And then the second step, which is the one that can be complicated like it was here, but it's not always. So the second step is to solve for y. So doing whatever is needed to get that back into the y equals form to get a formula for that inverse function.